T-test. This is the last section of parametric test to be studied in this year. Paired t-test is used to find out the pre and post-test effect on some experimental unit. That is to compare the pre-test score and post-test score of some intervention in economics, medicine, psychology or education. For example, we wanted to study whether a baby food dish increases the weight of the children or not. For this, we first choose a set of babies and take their weight. These weights are considered as the pre-test values, and we will administrate the food to the children for a specified period of time and take their weight after that. This is called the post-test values, and by comparing this we can able to say whether the food is effective in increasing the weight or not. Actually, there are two methods to evaluate the effect of this intervention. One method is to use the usual independent sample t-test to test the hypothesis, which we are already discussed in test 2. The second method is to use the paired t-test. In this case, the null hypothesis is H0 mu1 equal to mu2, and the alternative hypotheses are either H1 mu1 greater than mu2 if the intervention has a negative or reducing effect, or H1 mu1 less than mu2 if the intervention has a positive or increasing effect. Let xi, yi, I equal to 1 to n be the paired observation. That is, xi represent the pre-test values and yi represent the post-test value of the ith unit. Now we define ua equal to xi minus ya, and let u bar be the mean and su be the standard deviation of the differences, that is ua. Now the hypothesis we wanted to test is H0 mu1 minus mu2, which is a two sample hypothesis. Now we convert it into a one sample hypothesis as H0 mu1 minus mu2 equal to 0. That is, we test the hypothesis equivalent to H0 mu equal to mu0 with mu0 equal to 0. Instead of x, here we take u. And the test statistics is u bar into root of n minus 1 by su, which has t distribution with n minus 1 degrees of freedom. Normally, this test is applied for small samples. Now, we consider the various steps in testing the hypothesis. Let xi, yi as usual equal to 1 to n be the paired observation. Calculate ui equal to xi minus ya, I equal to 1 to n. Then calculate u bar, the mean and standard deviation su of the ua's. Then calculate the t value u bar into root of n minus 1 by su. For a given alpha, obtain the critical value from the t table corresponding to n minus 1 degrees of freedom. Finally, make the decision to accept or reject H0 based on the following criteria. For the hypothesis H1 mu1 greater than mu2, reject H0 if actual t greater than or equal to t alpha, and for the hypothesis H1 mu1 less than mu2, reject H0 if actual t less than or equal to minus t alpha, the tabled value. Usually, this test is used to compare the same pre and post-test value. Sometimes this is used to compare two values or two type of manuals or two type of medicines, etc. With equal number of observation in both the case. The example one is such a case where two manuals are applied to two fields and they are compared using paired t-test. In example 2, we compare the pre-test and post-test score of the children by giving a skill or training to repeat the words that are they hear once. Example 3, it is given ui instead of the actual xi and ya is ya, that is actual xi and ya are not given, but the difference ya minus xi, that is increase in weight, is given. So actually we need ui equal to xi minus ya, but here it is given ya equal to minus xi. So to test the hypothesis, first you have to convert xi minus ya into ui by multiplying it with minus 1 for every observation. Then go for the usual test and make the decision. This completes the parametric test. In the next section, we are going to study the non-parametric test. Thank you.